This is a question of two point sources which are placed on the same line, and the screen is placed perpendicular to the line joining the two coherent sources S1 and S2. Now, since these are the point sources, the interference pattern that occurs on the screen, that can be seen on the screen, it consists of concentric circles. And we are supposed to find out the radius of the nth bright ring, that is the first part. And the second part, we have given some values that the distance between the two sources is d, small d, and this is capital D, and the wavelength is lambda, which are given, the values are given. And we have to find out the radius of the closest second bright ring. Right. So let's first analyze the situation. Now this wave, which is emanated from point source S1 and point source S2, they will suffer a path difference of d cos theta. And if this path difference of d cos theta can be analyzed with respect to lambda, we can find out what type of interference will occur at point P. So let's start with our solution. Now, the path difference at P is given by delta x will be equal to S1P minus S2P, S1P minus S2P, which will be equal to d cos theta for small angles. Right. So we can say delta x equal to d cos theta, and for small angles, cos theta is approximately equal to 1 minus theta square by 2, and theta can be approximated to tan theta, which in this case tan theta will be equal to y upon d. So we can say delta x equal to 1 minus theta square by 2, or that can also be said to be 1 minus this is d into 1 minus theta square by 2. Just a second, I'll just correct this. So delta x is equal to d cos theta, delta x equal to d into 1 minus theta square by 2, and theta can be approximated to tan theta, which is equal to y upon d. So this will be equal to d into 1 minus theta can be written as y square upon 2d square. So that will be delta x. Now delta x is this. Now for bright ring, we can say that point P should be a maximum. So for a bright ring, delta x should be equal to n lambda for constructive interference. So we can say delta x is nothing but d into 1 minus y square by 2d square should be equal to n lambda. And as you can see from here, that y will be the distance from the central maxima or point O. So y will be the radius of nth bright ring. So y will say from here yn is nothing but the radius of nth bright ring. Yn is the radius of the nth bright ring, and it is given by yn is equal to yn, from calculating from here we get yn will be equal to d into under root of 2 into 1 minus n lambda by small d. That is the radius of the nth bright ring. Alright, so that is the first part of the question. This is the first part. The second part of the question, it is given to us that the distance between the slits, so distance between the two sources is 0.5 mm, the distance between the screen is 1 meter, wavelength is 5000 angstrom, and we have to find out the radius of the closest second bright ring. Now, as you can see, point O, at point O, this theta will be 0, so we can say this point O will be the central maximum. So, we can say at the central maxima, at the central maximum, at central maxima, theta equal to 0. Now theta equal to 0, so we can say if theta equal to 0, this cos theta will become 1, so delta x will be equal to d. Delta x will be equal to d. Delta x will be equal to d, and since it is central maxima, we can say this should be equal to n times lambda. Since it is a maxima, it should be n times lambda. So we get, if we want to find out what is the value of n for this point O, so we can say n is nothing but equal to d by lambda for the central maxima itself. So d is given to us as 0.5 mm, so 0.5 into 10 to the power minus 3 upon 5000 angstrom. Lambda is given as 5000 angstrom, so this is 5 into 10 to the power minus 7. So n comes out to be 10 to the power 3, that is 1000 here. N comes out to be 1000, that is central maxima will come for n equal to 1000. Now we want to find out the radius for the second closest bright ring. So first, this point O, this will be just a point, it will not be a ring. So the first ring will occur for n which is next to this, that will be 999, and then the second closest bright ring will be for n equal to 998. So for the second closest bright ring, n should be equal to 998, and thus using the values we can calculate its radius. So radius can be calculated to, it will come out to be approximately 6.32 centimeters. So that is the solution for this question. Thank you.